In the previous video, we talked about how sometimes you can get away with not actually having to solve for your absolute value equations or inequalities, depending on the question, as long as you just know your basic properties of absolute value. So now let's start talking about when you do actually start having to solve for or break down your absolute value expressions. And so there's really only two ways to solve for an absolute value equation or inequality. You can either try to do it algebraically, in which you are sort of proving the answer to yourself, or you can test numbers. And algebra, as I've said before, is usually my preference, which brings up the question, so when can I do algebra on my absolute value expressions? Well, I can do algebra when I can get rid of the absolute value signs, those two bars that make up the absolute value symbol. And so before we get into what I mean by that, let's take a little bit of a detour. It is not a big stretch to say that on the GMAT, there are only 4 mathematical symbols I care about, that I want to see on the page. That is plus sign, minus sign, division sign, multiplication sign. Almost any other symbol that I see, I can think of as meaningless, and I want to get rid of it. I want to put it in terms of one of these things. And so even something as simple as the percent sign, if I was to ask you, what is 50% of 60? Now, you might just reflexively say, oh, that is 30. But really what you did in your head is you said this percent sign is meaningless. And percent, what it really means is divide by 100. So 50% means 50 divided by 100. Of means multiply in this context. And so this can really be translated to 50% times 60. And that is what is equal to 30. So I'm trying to do something similar when I'm trying to solve absolute value equations. And so this brings up another question. So when can I get rid of my absolute value sign? And so let's look at a simple example that we've talked about before to see when I can get rid of the absolute value sign. And so we've seen these before. There was to tell you x is equal to 5, and then I was to ask you, what is x, absolute value of x, equal to? Well, in this case, absolute value of x is just absolute value of 5, so absolute value of x is also 5. Or, in other words, in this case, the absolute value of x is equal to x. Now say I was to give you a similar question. I was to tell you x is equal to negative 5, and then ask you what is the absolute value of x. Well, in this case, absolute value of x, or absolute value of negative 5, is also equal to 5. However, in this case, absolute value of x is equal to negative x. So if we put these two concepts together, what you might see is, well, the absolute value of x, and remember, x can be anything. X can just be a single integer, in these cases here, or x can be some other expression. X could be equal to 3a plus 2, or something like that. It doesn't matter. But either way, there are only going to be two options for what the absolute value of any variable x can be. It's either equal to itself, so absolute value of x is always going to be equal to x, or it's going to be equal to the negative of itself. Absolute value x will be equal to negative x. Now you can see why this sort of, I think, is where why people's head spin a bit when they start getting into complicated absolute value problems. Because in this case, negative x is actually equal to positive 5, right? Because x was equal to negative 5. And so sometimes with absolute value, you got to steer away from the terms positive and negative. And as we get into more complicated ones, I try to use the terms greater than 0 or less than 0 when talking about the value because of situations like this. What this means, though, is if the absolute value of x can only be equal to two things, well then, if you know what those two things are, you can just sort of write out those two options, then solve for those two equations individually. Then you can get your answer choices by getting rid of the absolute value signs. And so when are these two things going to be true? So this is going to be true whenever x is greater than 0. The absolute value of x is just equal to x, and then I can just plug x in into my equation in substitute of absolute value of x. And when x is less than 0, that's when we have this scenario here. Absolute value of x is equal to reverse of itself. And so as long as I can account for these two scenarios here, I can get rid of my absolute value signs. And so if we were to look at these in context a bit more. So when can I get rid of my absolute value sign? I can do it these cases over here. Here is where I can solve my absolute value problems with algebra. Here, in these more complicated ones, I usually have to test numbers. So in these simple examples, so simple means I only have either one variable, or really, what I should say is I have one variable under my absolute value sign, which makes it easy to get rid of the absolute value sign because in each of these cases, I only have two options. So for example, in this case here, absolute value of x is either going to be equal to x, which would mean, x is greater than 5 is one option, or it's going to be equal to negative x. And so either x is greater than 5 or negative x is greater than 5. And so when there's only two options, usually these are the ones where you have enough time to solve for both of these, and you can get rid of your absolute value sign. We don't need to do all of these here because we'll have plenty of examples, but we can even talk about something like this guy here. So when what's under the absolute value sign, x plus 7 greater than 0, the absolute value of x plus 7 is just equal to x plus 7. And so you can say one equation we have is just x plus 7 is equal to 10. Likewise, when what's under the absolute value sign is less than 0, it's equal to the reverse. So if you multiply this whole thing by negative 1, this is actually negative x minus is equal to 10. And so now we just have these two equations. We can solve for x in each of these cases to get our possible values for x. And so here, now you can see what makes these the more complicated examples. And so when I have multiple absolute value expressions or multiple variables under my absolute value bars, well, now you need to account for a lot more scenarios because you have the case where this guy could be greater than 0. This guy is greater than 0. But you can also say, well, what if this guy is greater than 0 and this guy is less than 0? Or this guy is less than 0 and this guy is greater than 0? Or what if they're both less than 0? And so here we would have 4 scenarios and we would have to test every single one of those and or solve every single one of those if we were trying to do it algebraically. And so Might be a case where testing numbers is the better option. So let's take a look at some more of these simple examples though. And so here's the most simple you can get. And these ones, I can do these just in my head. So where I have just a single variable under my absolute value sign, then I'm comparing it just to a lone integer on the other side of my inequality. And so for this one, so if x is an integer, what is x? And then our first statement. So we don't know anything about x other than it's an integer, which can be relevant, especially when we're talking about inequalities. First statement says absolute value of x is less than 3. And so when I have these really simple ones where I just have a single variable and an integer, just sort of think about it using a number line. I have 3 here, negative 3 here. So if it's telling us the distance x is from 0 is less than 3. So what does that mean? So you can, if you just want to find all of the values, the easy thing you can do is just sort of start at the extreme. So if I start at 3, so x cannot be equal to 3 because that's not less than 3 away. So if I go 1 to the right and say, can x be 3.1? Well, no, because now that's more than 3 away. So you got to go the other way, right? So x can x be less than 3? And absolutely. And so we can, one of our boundaries, we can say, okay, x has got to be less than 3. And then we keep going. Can x be 2? Yes. Can x be 1? Yes. Can x be 0? Yes. Can x be negative 1? Yes. Can x be negative 2? Yes. Can x be negative 3? No, because absolute value of negative 3 is equal to 3, but it's not less than 3. So this, you can sort of just use a number line. Get rid of your absolute value sign. This is telling me x is between negative 3 and 3. What about this guy here? Now really the only thing different other than the numbers here is here we have a x is less than something. Here we have absolute value of x is greater than something. So how does that change things? So if absolute value of x is greater than 1, do the same thing. So if we started our extreme here, 1, so if we go to the left, can x be 1/2? It cannot, because absolute value of 1/2 is not greater than 1. Can x be 1.1? Absolutely. So if we keep going to the right, any of those values will work for x. So we know we want to get rid of our absolute value sign. So x can be greater than 1. It's one option. And then remember, we got to test our other extreme. So even though x can't be a positive fraction, then if we keep going, can x be 0? No, x cannot be 0. Can x be a negative fraction? It cannot, because x is negative 1/2. Absolute value of negative 1/2 is still 1/2, which is not greater than 1. Then we get to negative 1. X cannot be equal to negative 1, because absolute value of negative 1 is equal to 1, not greater than 1. But negative 1.1, absolutely. So when x is negative, x has to be less than negative 1. Which is different. So in this first statement here, we sort of had this and scenario. X has to be greater than negative 3 and less than 3, because it is this between situation. Here, we have this or scenario. And if we were to diagram this on our number lines, x is greater than 1 or x is less than negative 1. That would look like this. Whereas our first statement would look this. Our second statement is sort of these two-tailed, open-ended tails, where here we have a close. And so these translations here, easiest ones, and I can make these reflectively. So whether or not you have this and scenario here or this two-tailed or scenario, all that determines that is which way the inequality sign is facing. So if it's absolute value of x less than some integer, S then gives you this and scenario, where absolute value of something greater than some integer gives you this or scenario. Now we actually have to answer a question. It's a data sufficiency question. And so we want to know what is x. So based on statement 1, we know x is between -3 and 3. There are still multiple options for x, so that's insufficient. Knowing that x is greater than 1 or x can be less than -1 still gives you infinite options for x. So statement 2 is insufficient. And statements 1 and 2 together, you just need to think a little bit. So one way you can do it is you can sort of break down what do you know about x when it's positive and when it's negative. So when x is positive, from statement 1, you know x has to be less than 3. From statement 2, you know it's got to be greater than 1. If x has to be between 1 and 3, and it's got to be an integer, remember we know that from the prompt, this means x has to be equal to 2. And x is greater than 0. What about though x is negative? When x is less than 0, we know it's got to be greater than -3 from statement 1, and it's got to be less than -1 from statement 2, which means when x is less than 0, x is equal to -2. And so even when we look at them together, we still have two options for x, which is less than infinite, but not less enough to make this sufficient. And so our answer is still E. We will do another video looking at these simpler absolute value inequalities and equations in the next video.